In this video, we're going to talk about 2.3 Objective 1, where we explain techniques to compute limits. How is the limit as x approaches a of p of x calculated if p is a polynomial function? Just going to evaluate p of a, which is b. We'll explain more about why that is later when we talk about the concept of continuity. For what values of a does limit of r of x as x approaches a equal r of a if r is a rational function? It would be those values of a for which the denominator of the function is not 0, otherwise known as its entire domain. How are limit as x approaches a from the left of p of x and limit as x approaches a from the right of p of x calculated if p is a polynomial function? Same thing, plug it in and you get p of a. So determine whether the following statements are true and give an explanation or counterexample. Assume that a and l are finite numbers. So if limit of f of x as x approaches a is l, then f of a is l. That's not necessarily true. We could have the limit exist and have the point separate from it. For example, I could have a function that would look like that. It was piecewise defined. Statement is false if f of x equals 1 when x is not 0 and equals 0 when x equals 0. Then the limit of f of x as x approaches 0 is 1, but f of 0 equals 0, which is not 1. So that's C. It's basically the same kind of idea as what I was talking about. If the limit of f of x equals L as x approaches a from the left, then the limit of f of x equals L as x approaches a from the right. No, that's not true. We can have a limit exist and from the left and the right and be different numbers. So that's going to be A. Statement is false. And they're using y equals 1 from the left and y equals 0 from the right as their examples. If f of x, limit of f of x as x approaches a is L, and limit of g of x as x approaches a is L, then f of a equals g of a. No, because again, the limit value has nothing to do with the function value necessarily. So we use the example, the statement is false. If f of x equals x cubed minus 8 over 4 times x minus 2, and g of x equals x squared plus 2x plus 4 over 4. In both cases, the limit as x approaches 2 of f of x equals the limit as x approaches 2 of g of x equals 3. But g of 2 equals 3, but f of 2 does not exist. So that was D. The limit of the quotient of f of x over g of x as x approaches a does not exist if g of a is equal to 0. That's not quite right either. It doesn't exist if the limit as x approaches a of g of x equals 0. So if f of x equals x squared minus 4 and g of x equals x minus 2, then limit as x approaches 2 of f of x over g of x exists, and it is 4, even though the denominator would have been 0, so that's B. And then E, which is our last question here. If the limit of the square root of f of x as x approaches 1 from the right equals the square root of the limit of f of x as x approaches 1 from the right, it follows that the limit of the square root of f of x as x approaches 1 is equal to the limit of f of x as x approaches 1. So not necessarily because you've just done one side from the right, it doesn't necessarily mean that there's behavior from the left at all. If f of x equals x minus 1, then the limit of f of x of the square root of f of x, which equals the limit as x approaches 1 from the right of f of x, is equal to 0. However, limit of the square root of f of x as x approaches 1 does not exist because the limit of the square root of f of x as x approaches 1 from the left does not exist. So those were all things that people assume that are not true. And we explained why they were not true. All right, that's it for this video. We'll come back next time and talk about 2.3 Objective 2. See you for the next video.